In this video, an introduction to physics, we are going to discuss about physical quantities, base units, derived units, units and measurements, and the coefficients involved. Now, the first question that I might ask is, what is a physical quantity? What do you understand by the term physical quantity? Well, a physical quantity can be defined as a measurable feature of an object. A measurable feature of an object, or a material or system that can be measured. A physical quantity is a measurable feature of an object. Now, there are two types of physical quantities we need to be familiar with. They are what we call the base or the fundamental quantities and the derived quantities. So, what are base quantities or fundamental quantities? So this can be defined as those quantities that cannot be expressed in terms of other quantities. Base quantities are those quantities that cannot be expressed in terms of other quantities. These include length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. So there are 7 of them. We need to be familiar with them. So we have length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Now these are what we call the base quantities. For example, length. Length, which is the distance between two points, one point and the other. So there is no other quantity we can express length into, but it's just length alone, just like that. It cannot be expressed, or distance, we cannot express distance into other quantities, so it is just length. For example, also time, the duration of an event. We cannot express time in other quantities, so an event will take place in a specific amount of time, a specified amount of time. So those are the base quantities. Now we need to also know the units involved with these quantities. With length, we use different types of units to measure length, but we have what we call the SI units. The SI units are the accepted units which are used by most of the countries. They were accepted, but there are some other units. They include the British or the imperial system of units which are used, but the countries accepted what we call the SI units. So for length, the SI unit for length is the meter with small letter m, as you can see. Time is second with small letter s. Mass, kilogram, small letters kg. Now look at electric current and temperature. We see that when writing electric current and temperature, we use the names of people. Ampere and Kelvin, those are the names of people. So when writing ampere, we use small letters to write these names for the SI names. We use small letters, but when we write the symbols, we use capital letters A and K for electric current and temperature respectively. We need to know that. Now let's move on to the derived quantities. So what are derived quantities? As you might have guessed, derived quantities are those quantities which can be expressed in terms of other quantities. So some good examples are there in the table of derived quantities. We have speed, acceleration, volume, force. Now, why do we say they are direct quantities? Well, as you may see, for example, speed. We know the formula for speed. We say speed, I'll use letter S for speed. Speed is equal to distance over time. So for us to get speed, the S, we have combined two things. The distance, which is a base quantity, distance, which is length. This is a base quantity. And time, it's also a base quantity. So we know that direct quantities can come from base quantities. So they can also come from direct quantities. For example, let us look at force. I'll use capital letter F for force. Force, we know that force is equal to mass times acceleration. Now we know that mass is a base quantity. So mass is a base quantity. Acceleration is a direct quantity, just like force. So acceleration is a direct quantity. Now, why do we say acceleration is a direct quantity? So acceleration, we know that acceleration is equal to velocity divided by time. So we see that acceleration is also coming from something. So acceleration is equal to velocity over time. So we can see that force is made up of mass times acceleration. Mass is a base quantity, acceleration is a direct quantity.